To solve this differential equation is x square y double dash minus 2xy dash plus 2y equal to 0. This is my Cauchy Euler equation. X is bigger than 0. As I was mentioning before, we have the equation like this one: a x square y double dash plus b x y dash plus c y equal to 0. Then my characteristic equation when we make the substitution, y is equal to x to power m will be m square plus b minus a m plus c equal to 0. So solving this one, I want to find the characteristic equation. Here my x is bigger than 0, and I having here my a is equal to 1, my b is equal to minus 2, my c is equal to 2. I substitute in this one m square plus b minus a m plus c equal to 0. That give me m square b minus a, this minus 2 minus 1 minus 3m, c is 2, is equal to 0. Now I can factorize this one. My factors will be m minus 1 into m minus 2 equal to 0. We multiply, we get here plus 2, and we add, we get minus 3. So I get the roots. My roots are m equal to 1 and m equal to 2. So I can write my general solution: y equals c1 x to power m1 plus c2 x to power m2. That's my solution of the problem. Next example is example 3. We are having third order differential equation, and we try to solve the differential equation. My differential equation is x cube y triple dash minus x square y double dash. Then we having here minus 2x y dash minus 4y equal to 0, where x is bigger than 0. is Cauchy Euler equation. Of substitution will be y is equal to x to power m. What's y dash? Y dash is m x to power m minus 1. What's y double dash? Y double dash is m into m minus 1 x to power m minus 2. Y triple dash will be m minus 1 m minus 2 x to power m minus 3. So simply we just go on differentiating. We get y dash, y double dash, y triple dash. I am having xy dash, then this one will disappear. Xy dash is equal to m x to power m, x square y double dash. These two will be removed, and we get here m minus 1 into x to power m. Then x cube y triple dash, that will give me m minus 1 into m minus 2 x to power m. We substitute in our differential equation the values and take x to power m common, and we have the condition m to x to power m is not equal to 0. I get here the characteristic equation as m minus 1 into m minus 2. Then minus xy double dash, x square y double dash, not x. So you get here minus 2, minus into, not to minus, into m minus 1. Then we have minus 2xy dash, so multiply minus 2m, and then minus 4 equal to 0. When I simplify this one, I'll get the equation as m to power 3 minus 4 m to power 2. Then we have plus m minus 4 equal to 0. Again, here you need the skills of factorization. And if you're good in factorization, then especially these problems with the constant coefficient and the variable coefficient are very easy for you, because you just want to find the roots, or to find the roots you can write your general solution. Now here, when you're having 4 terms, to make the pairs, we take these 2 pairs and take those 2 pairs, take common. We get here m square common and get here m minus 1. You get here 1 common and get here, m minus 4, and get m minus 4 equal to 0. Take m minus 4 common, and we'll get here m square plus 1 equal to 0. So we're having m minus 4 equal to 0, that give me m equal to 4, and m square plus 1 equal to 0 will give me m is equal to plus minus I. This is complex root. Now I can write my general solution. My general solution is y is equal to c1 x to power 4, this is my m1, plus c2 alpha is 0, x to power 0 is 1. We get here c2 cosine beta is 1, ln of x, plus c3 sine ln of x. So these are the ideas we are having here. The case we have two different values of m1, m2 not equal. Here we are having the values real and also imaginary. So you can do more example, more exercises to understand it. The next idea is to solve the Cauchy Euler equation now in non-homogeneous form. Before that we are using the method for solving the homogeneous differential equation. So for example, I have this equation. This here is a x square y double dash plus b x y dash plus c y is equal to g of x. Now this is the Cauchy Euler equation which is in the form of non-homogeneous. So again the result we were going to find here y is equal to yc plus yp. Yc is the homogeneous part. Yp we can find yp by using variation of parameter. We already discussed the variation of parameter method. So we apply that one to solve the Cauchy Euler equation. So yc is same as we have done before. This is my step 1. Step 1 will be to find yc. My equation is a x square y double dash plus b xy dash plus cy equal to 0. Now make the substitution. Let y is equal to x power m. I get the characteristic equation a m square plus b minus a m plus c equal to 0. I get two solutions m1 and m2, and correspondingly I'll get two solutions y1 and y2. So my general solution will be y equal to c1 y1 plus c2 y2. Now number 2, step 2 is to find yp. So what I said to find yp, I use the method of variation of parameter. I will use this method. So what's my yp? My yp will be equal to u1 y1 plus u2 y2. Now what's my u1? You know what my u1? u1 is w1 over w u1 dash, and u2 dash is equal to w2 over w. I'll show you this with the help of example, details of this method. I take this example. I've given here the Cauchy Euler equation. Solve the Cauchy Euler equation. Here is x square y double dash plus xy dash minus y is x square e to power x. X is bigger than 0. So solution of this one, we take two parts. Find yc. We take here x square y double dash plus x y dash minus y equal to 0. We make the substitution y is equal to x to power m. My a is equal to 1. My b is equal to 1. My c is equal to 1 is 1. I get here m square plus b minus a, m plus c equal to 0. That gives me m square minus 1 equal to 0. I get the roots m equal to 1 and m equal to minus 1. So using the roots, I can write my yc is equal to c1 x plus c2 x to power minus 1. So this was part 1. And part 2 is to find yp, I'm given here my y1 is equal to x, my y2 is equal to x to the power minus 1. What's my f of x? Now my f of x will be always equal to, that's why I told you last time why I'm using this g of x. So I say here my f of x is equal to g of x over a2 x squared. This you must not forget. So I am having here the equation here my g of x is equal to x squared e to the power x, and my coefficient of I double dash is x squared. So my f of x is equal to g of x is x squared e to the power x over x squared. So that's e to the power x. So I can write here this my f of x is equal to e to the power x. Now we can find my w, as in case we are having here the variation of parameter, this method. So my w is equal to y1 is x, y2 is 1 upon x, y1 derivative of this one is 1, derivative of this one minus 1 upon x squared. So we just solve it. Multiply, we get here minus 1 upon x is equal to minus 2 upon x. This is my w. Now I write here my w1 and I write here the formula for finding u1. My u1 dash is equal to minus y2 f of x over w. What's my y2? My y2 is 1 upon x. What's my f of x? My f of x is e to the power x. What's my w? My w is minus 2 upon x. So minus is cancelled, minus x is cancelled with x. We get here 1 by 2 e to the power x. This is u1 dash. Now write my u2 dash. My u2 dash is equal to y1 f of x over w. What's my y1? My y1 is x. What's my f of x? My f of x is e to the power x. And my y2 is minus 2 upon x. So get here minus 1 by 2 x squared e to the power x. This is my u2. And we want to solve this one. And to find here u1, we integrate it. u1 is equal to integral. We get here 1 by 2 out. E to the power x dx is equal to 1 by 2 e to the power x. u2 is equal to minus 1 by 2 x squared e to the power x dx. Here I give you a very nice method to find the solution. We're having x squared by 2x. Take the derivative, we get here 2x. Take integral e to the power x. Take the derivative, we get here 2. Take the integral e to the power x. Take the derivative 0. Take the integral e to the power x. Now multiply here. The first one with positive sign, second one with negative sign, third one with positive sign, and we get here the integration of this one. This here is minus 1 by 2 out. I get here x squared e to the power x, then minus 2 x e to the power x plus 2 e to the power x. That's my u2. Now I substitute here. This is my equation yp. So what's my p when this is my y? Then my yp was equal to u1 x plus u2 x to the power minus 1. So u1 I multiply by x to get my yp. So here is yp. So I get here yp is equal to u1 multiplied by x. So here is my u1. I get 1 by 2 x e to the power x. Then I have here u2 multiplied by x to the power minus 1. We divide by x, 1 upon x. So it's minus 1 by 2, minus 1 by 2. We divide by x, get here minus 2 out, this here, and then I'm getting here the values of x e to the power x minus 2 e to the power x. Then here 2 upon x e to the power x. So simplify this one. I get here yp. When I open this one, then this 2 will be cancelled. This minus become plus. We get here e to the power x. Then this minus and then this 2 is cancelled. And we get minus 1 upon x e to the power x. So this is my yp. I can write my general solution. My general solution is y equal to yc c1x plus c2 x to the power minus 1 plus yp is plus e to the power x minus 1 upon x e to the power x. So this is my general solution for this differential equation which I am having here. This is my differential equation, non-homogeneous differential equation with variable coefficient, and especially in the form of the Cauchy Euler equation. We find first the solution for the homogeneous part, yc. So this is my yc, and then yp is equal to u1 y1 plus u2 y2. This is my y1, this is my y2, and f of x. For f of x, we divide by the g of x with x square, we get e to the power x. Now my w is y1, y2, y1 dash, y2 dash, we get minus 2 upon x. Now I can write here y1 u1 dash is minus y2 f x over w, u2 dash is y1 x upon w. Integrating this one, we get here u1. Integrating this one, we get here u2. I just told you about this one, this long by parts. Instead of doing by parts, we can have the very easy one. This is which is going to be eliminated to 0 by taking the derivative, x squared 2x2 and 0. Then this is just repeating e to the power x, e to the power x, e to the power x. Then plus minus plus, we get here the solution for this one. And yp, you substitute, multiply this one by x and multiply this one by 1 upon x. We get here yp. Then we write our general solution. The general solution is y is equal to yc plus yp. So this is method as we did the many problems for the variation of parameter. Similarly, you can solve more problem for variation pattern parameter, and you can consult my notes for more example. We given here in the description. We have given the link of the notes. Again, we'll be continuing with the more videos on differential equation. If you want to get the information, you subscribe our channel and also the bell icon so that we can get the notification. Thank you very much.